Hi everyone. In the previous video, we learned about Sentinel-1, ISCE2, and Mintpy, and how they are completely a pack for inside workflow. Now it is time we need to understand about the Sentinel data. So before we create an interferogram or run ISCE2 or process any data in Mintpy, we first need to know how to download the Sentinel-1 SLC products. In this video, I will show you exactly how to search, how to select, and how to download the Sentinel-1 for insert processing. In the previous video, I've shown you from the Copernicus website in which you will be specifically downloading one or two data sets. But this we'll be going in deep so we can get all the imageries at a time. So first what we need to do is we need to open one more website. It is Alaska ASF datasets. I'll be showing you soon. So before that, we need to understand the processing. So we are taking the Sentinel-1 imagery, and then we are using the IW mode, and then we are going for the SLC product. So if you see for Mintpy, we need the SLC product. That means single loop complex. We are not supposed to use the GRD file. That means it's a grid file that is used for flood mapping and general radar analysis. In the coming videos or coming series, I'll explain you how to use the GRD data for the flood mapping and radar analysis also. Now we are into subsidiaries regarding the land. So we'll go for the SLC, single loop complex images. So what we have to do is we just need to go to easiest way, go to Google and type Alaska ASF data set, data vertex. So here you can see this one. So this website contains all the data. So what you can do is you just select any location. For example, if I wanted to go for any particular area like this, say example, I can zoom in and then I can pull out the site. See, I wanted to do a study on the northeastern part of India because it contains more of landslides and more of natural disasters. So we'll just focus on that one. So if I want, I can zoom in more and then say example, I can take Nagaland as an example. In this, I can take one most popular place for the hornbill. I am selecting for the Kohima here and then I click on that and here I'm having this Sentinel-1. If I want, I can change into any of them. But right now, I'm taking only Sentinel-1 because it starts from 2014 to the present. So I wanted to check how the displacement is changing from 2014 or 2017 to present. So I am just selecting this one and you have the filter here. So you just go to the filter and then you can select one start date. Say example, it starts from 2014. So I'll just go with 2016 or 17. I'll go with 2017, 1st of January, and then end date I can go for 2000. Say I can go for 2026, but I'll just go for 2025 and one. Once you press this one, you are giving a date filter. Then you have to go for one more thing. That is, see, the one which I'm telling SLC single loop complex. You need to select this one. If you select any of these, then it will be for the flood mapping and other things. I'll also explain you in coming videos or coming sessions what are these meant to be. So first now I'm selecting only SLC and here B mode. Usually when you download the Sentinel-1 imagery SLC, you will find this IW. Okay, you can just select that one and then you can select any of them or they just keep it like this and then you can understand like which is more useful. Okay, so here I've selected this one and then we need to go for SLC and then we'll just go for search. So before searching, I have the orbit direction also. That means the satellite whether it is moving in the ascending or the descending direction. So I can just go for the ascending, and then I'll say okay. And from here you can see 504 files are available. If I click on descending, and so you'll see descending 650. So whichever you want, you can use them. So I'm just going with the ascending part. See, ascending is from south to north direction, and when you are descending, it is north to south direction. So if you are going like a uh, recording any kind of ascending or descending, you just check the quality of the images also. Now, just for the video, I'm taking the ascending, and they have 504 files, and just click search. So this is one of the best place where you can get all the data at a time. And we also need to find the relative orbit also. See, here when I am using this one, you can see this particular area. There are many images, right? Many acquisitions. So you select one place in which the whole study area is covered. See, this one, it's not covered completely, approximate place only. This one also, it is not too good. So you just select one or two images and then find out in which location the data is exactly placing. For example, this one, if I click, or you can go for the zoom to scene. So it's showing the red one, and here also it's not that good. Just go again. So keep on checking with the proper location so that you get the maximum coverage of the whole area. So if for me, this, see, my focus area, my study area is at this particular location, Chumukirima. So I'm just selecting one image here like this. Okay, so this particular area got highlighted, and what I can do is I just click on more like this. So once you click more like this, you can see the similar acquisitions from May 2026, May 2025. So if you go on completely, you can see many images, 249 scenes that are covering this particular area of interest. So what you can do is you can go for add all results to download, add 249 files, and then you can go to the downloads, and then you can click the download. That way your data will be downloaded into your PC. This is one best thing. So try to search for the proper data which is covering your area of interest, and from there you can use the acquisition, and from there you can do the processing in ISCE2, and then from there you can go for the data for Mintpy. So for now, I'm just showing you the process of how to download the data, and in the next coming videos, I'll explain you like how do we install the ISCE2 in Ubuntu, and then how do we use the Sentinel-1 scenes to generate our interferogram. From there, you can understand clearly the deformation analysis. So please do watch the remaining videos, and please do subscribe for Geoscience Engineering. Thank you for watching.